Okay, so let's get started. Lab. Here's a physical copy of the lab. It's online. Yes, you've already started.
Let me look this up.
We're gonna do a little bit more trig first, and I'm gonna give you time to work on the lab and on the trig stuff.
It is the same game we played, where you push the thing, it's covered by. Yeah, sounds like fun.
This one is not necessarily for today.
That doesn't make sense. That's kind of fun. Middle finger. It's kind of weird.
Kind of like I had a student ask me what bondage pants were class one day, and
yeah.
I didn't
Oh,
think I
wow.
could that one either.
You should have answered that. That would have been interesting.
After I guffawed, I walked out of the room and let somebody else handle it. So, all right. Welcome back. Hope everybody had a good weekend. Glad our football team won. I know that meant a lot to them. It's been a rough season for them. Well, partly just being ahead at times and then not being able to finish it off. So let's trig for a minute. Okay, so those of you that are online, I'm going to pull up the notebook so hopefully you can see that behind me. So we're on forces. And the lab that you need to have done here the next day or two is the lab that says Lab 1 Forces. It was from before fall break. So you're going to see it right there. Right there. And so that's the one I just handed out physical copies for them. But what I want to look at today is I want to look at the Newton's laws and practice problems in solving right triangles for a little while, and then I'll let you guys go, or you can stay and work. And if you have questions, you can ask, and I'll be working with them as they have questions. So let's look at this one. So if you got that from last week, and you need to get me this. Not physics 2. You probably don't want to do any thermodynamics. But you haven't been here to do thermodynamics. You got, oh, that's right. You got yours before you left. Way to be responsive. Be on top of it. Did I give you this one as well? Yeah.
This is not as bad as getting hands rubbing. Yeah, that was right.
Okay. So let's start with, yes, London. What, on Friday? Did I just miss you? I'm sorry.
Wow. You're excluding students then?
Yeah. Yeah, no, sort of felt like a Cubs game. So I was totally sympathetic with that.
I'm so used to it, just watching Titans game.
No. One of these. Two of those. And then.
I can be really good for those who see the playoff.
Okay, so a couple of things. Thing one. Which problem do you want to work first?
One through,
I'm not going to work all of them. So there was a suggestion for one, so I'll do that. And then somebody else can pick another one. We'll do a couple of 3 of these. We'll see. Okay, so on number one of the questions I was getting from the online students is, how do you know which pieces of information you have? So in this case, the angle we're given is 72. There's the angle we're given. I'm going to zoom this up just a little bit and make sure that now it's off the screen. Okay. Yeah, that should be shown. So the 72 is right there. So when I see what I have been given this side right here and this side right here. Those two sides form the 72-degree angle. So that we know that the longest side, which in this case is X, is the hypotenuse. And what is the 6? What would we call the 6? Is it the adjacent side or is it the opposite side? This one is adjacent. How do I know it's the adjacent? What am I looking for? It helps form the angle. The word adjacent means beside, so it helps form the angle given. So that's why it's the adjacent side. And so when we want to solve for X, we have adjacent over hypotenuse equals which? Adjacent goes with which? Sine, cosine, or tangent? Adjacent over hypotenuse. No, adjacent goes with cosine. So adjacent is the cosine of 72 degrees. So then I pull out my calculator. Yes, you may. If you're on a computer, I don't know if you realize this, but the Google bar is a calculator. So, and there's Desmos as well if you want to use an online one. So either one of those are fine. All right, so we want to do the cosine 72, find the cosine, and it's 0.3090. So 6 over x equals 0.3090. Right there in those bags. So here's where we're at. Now, we've got to get x out of the denominator. To get x out of the denominator, we're going to multiply both sides by x. So 6 equals 0.3090x. And we divide by 3090. And we get x equals, calculator back up, take that answer, whoops, 3 plus 6 divided by, recall, and I get, oh shoot, 6 divided by 0.3090 is 19.4. 19.4. I asked for it to the nearest tenth. So 19.4 would be our answer there.
Did you divide 6 divided by 20?
Yes, I did. So when you have your variable in the denominator, you have to multiply to get it out of the denominator. You multiply by the reciprocal, just like you would in algebra class. And then you solve for x, and since it's now 0.3090 times x, you divide both sides by 0.3090 to get the value you're looking for. So that would be number 1. And feel free, folks over on this side, you guys can feel free to unmute and ask questions, or you can chat box something to me. Let me see if I can see that. Okay, get that up too. So there you go. All right, questions that you guys out there have? I can't see you around my computer. Okay, so pick another one.
6.
Number 6. Okay, so number 6, What sides are we given here?
14 and 50. 14
The
and X.
opposite. Oh,
14 and X, and our angle is the 51. So in this case, X is going to be still our hypotenuse, longest side or opposite the right angle. And now the angle, the other side that I know is the 14. And the 14, if you look at this, you'll see that the 51 is down here in the lower right, left-hand side. 14 does not, that side does not touch the angle. It does not help make the angle, which means that the 14, the side that we've got labeled 14, would be called the opposite side this time. So opposite over hypotenuse is which?
sine.
That would be our sine of 52 or 51. So then we get that equals 14 over X. So I'm going to show you another way to work this problem. Let's get sine of 51 real quick. 51, show me the sine, 0.7771. Okay. So you can also do this. Put that over a 1. And some of you are more familiar with this process. You cross multiply. Cross multiply applies a cross and equal sign. You have to have an equal sign for this to happen. So this will give you 0.7771x equals 14. So x equals 14 divided by 0.7771. And that turns out to be 14 divided by 0.7771, which is 18.0 to the nearest tenth. Okay, so let's pick one from the back side. Pick one from the back side.
Number 2.
Number 16. Look at that.
Back side. Yeah, that one.
This one?
Nope, the one we got on Friday or
Last week.
Thursday. Yeah.
Wednesday.
Wednesday.
Was it Thursday?
Thursday, Wednesday, would have been Wednesday. Yeah, because Friday was an odd day, except we didn't count it because we kind of weren't in class. We were, but it was weird. Friday
I
was
liked
weird.
you here on Friday, by the way.
That's my business, yes.
Sorry.
It's okay. Not upset. Just don't feel the urge to answer. Okay, so but now that we've created a scene about it, I had medical imaging that I had to get done, and all my tests came back clean.
That's
So I don't have to go for another year. All right, so which one did you say, 16?
Mhm.
16? Okay, 16. 16's upside down. Or at least that's what my students ask me. Why is this one upside down? I know what they look like if they're right side up. And I'm like, yeah, but you should be able to handle it anyway. So here's our angle. And the sides we know are these two. So this time we know the adjacent side and the hypotenuse. The adjacent side is the 34. The hypotenuse is x. And our angle is 59. So adjacent over hypotenuse would be cosine of 59. So if you like, you can put that over 1. Let's see. 59 cosine Wait, 5150. Over 1. So again, we cross multiply. We get 34 equals 0.5150x. So x is 34 divided by 0.5150, and I get 66.0 rounded to the nearest tenth. Okay. So hopefully this, for most of you, feels comfortable. If it doesn't, it's okay. We'll keep working at it, okay? We'll be doing this kind of stuff the rest of the year. So this is about as hard as the math gets. Really. We occasionally do a quadratic formula just for funsies, but not very often. Yep. But almost all the math we do in here is this piece of geometry or trigonometry, being able to do sine, cosine, tangent. And if you never had them before, which I always have kids in here that have never seen them yet, that's okay. We'll just work at them. Okay, so now we're going to leave that page. Yes, we're going to leave that page. And we're going to come over here to the ones I just handed out to you. Because this is how this applies in physics. So I've already given you those. We've already did those. So here's our new bit. Download this. Wait for it to open. Yep.
Wednesday as well.
Yeah. Well, no, the part that I'm giving you today are these.
Okay.
So this is today's, but it is part of the same packet that went out on Wednesday. Okay, so here's what happens. Now we have to be able to handle things that happen in two-dimensional space. So up until now in physics, everything we've done has been in 1D. And what we mean by 1D is one-dimensional. You can move forward, you can move backwards. That's it. Or you can move right, you can move left. That's it. You can move up, you can move down. That's it. That's the only axis you get to work on. But now that we get to forces, we're going to make this a little bit more realistic in the sense that we're going to let you have left and right as well as up and down. Okay? So we've taught you kind of how to do one dimension. Now we're going to do two. And in fact, the nice thing about this is we won't go to 3. But if you do 3, it's the exact same thing you do for 1 and 2. You just have to do 3 dimensions instead of 2. So instead of breaking things into their components for like this one, this force up here, the 13 newtons, it has a component that goes up. Part of that force goes up, pulls the object up. Part of that force pulls the object to the right. If it was 3 dimensions, you'd have to split it up into the part that lets you go left or right, the part that lets you go up or down, or the part that goes in and out of the board. But doing this in 3 dimensions on a 2-dimensional surface is tricky because it's hard to draw things that look 3D on a flat surface. You know what I mean? So that's what we have to deal with. But what we're going to be doing here is, why are we using the trig? Well, the trig is going to tell us how much of our force goes to the right and left and how much of our force goes up and down. All right. So let's do the same thing we just did before. I'm going to work some of these with you, and then we're going to stop and let you guys work, and you guys can work and take questions, and I'll come around the room and so forth. So first thing we have to remember, what is our key formula for this piece of information or this relationship? Well, our key formula is that force is mass times acceleration. Newton's second law. So on number one, the picture on the left, what is our net force? Which one of our forces is unbalanced?
Applied force 12 newtons.
The force applied that is 12 newtons is our net force. And the problem asked me to find the acceleration. So I start out, force is mass times acceleration, and immediately I hit a wall in solving this problem. What's the wall? I don't know the mass. And I can't do math if I don't know two things. I have to know two of the three things to find the third one, right? All right. So what can I use to find the mass? So I'm going to use gravity, because the force due to gravity is what? Mass times 10. You got it. She is on fire today. Killing it. So the force due to gravity, the reason we like it is because it's always mass times 10, because the acceleration due to gravity, we're rounding it off to 10.
So since we know the gravity already, we just divide it by 10.
Right. So since we know this is 19.6, and this is mass times 10, our mass would be 19.6 divided by 10. So our mass is 1.96. So to come over here, find mass. Now I take my mass and I come back. 12 equals 1.96 A. Equals 1.96 A. So then I pull out a calculator. 12 divided by 1.96, 6.1. 6.1 meters per second squared is our acceleration. So that was a sort of two-step process. And I'll wait and see if anybody has questions. Yes, sir. Yes, sir, you may.
Thank you.
Oop. There we go. So any of you in distance learning land, feel free to either chat back a question or just unmute and ask. I think I've got the volume turned up. Yeah, I got the volume turned up loud enough for me to be able to hear you. Okay. So let's look at the second part of that question. I'm gonna erase this. Has everybody got what they need off this first bit? Okay. All right. So erase this off. All right. So what do we have on the second problem? What is our net force? Are we balanced up and down?
Yes.
We have 19.6 up, 19.6 down. So I am balanced vertically, but horizontally I am unbalanced. What's my net force this time?
Well, no. 4.
It's 12 is to the right, 8 is to the left, so we give it a negative sign. We now know our mass because what?
Is 4.
Because we did the mass on the last problem. So yes, our net force is 4 newtons to the right. So 4 equals 1.96 times acceleration. So 4 divided by 1.96 is A. So acceleration is a little more than 2. 4 divided by 1.96, 2.04. So we'll just round that off till 2. 2 meters per second squared to the right.
Wait, it's just 2 even?
No, it's 2.04. But since nearest 10th would just be 2, so we're fine. Usually in here we round off to 1 or 2 decimal places. Okay. Wait to hear if there's any questions. Drink some more water. So we've got a 5-day week this week and a 5-day week next week. And then you have a 4-day week again.
And then we're done with school.
No. Because of voting day, which I've already done my voting.
Me
When are we
too.
out of school?
November 3rd,
Oh.
election day.
I already
So-
did my voting.
You did?
Yeah,
Were you able to vote this year in the national one or just?
I was just doing.
Okay. Well, I have some students that are mad because their birthday's like in December, and some students who are excited because they're going to get to vote for the
Mine
first
is in
time.
December,
So-
but I'll be.
You had to be within 3 months of the 18. Okay, So- hold up. So now that we've kind of reviewed how you do the net forces and force due to gravity to find mass, now we have to
Fine.
get a little bit further into the problems. Okay,
Sugar your trash.
so. All right, so forces, horizontal and vertical components. What are they actually asking me here? They're asking me to find the legs of the triangle. So number 2 asks you to find the legs of the triangle. So we're going to do this one by way of notes, and then I'm going to do the first one on number 3 for notes, and then we're going to take a break, and you guys can start working on this where I'm here to help. Okay. So how are we going to find the force X, the X leg?
By using the units. Okay.
Is it the cosine or is that the sine piece?
Sine. The cosine.
It's the cosine of 23. This is just a straightforward 23 cosine. So that equals 0.9205. And then we're going to multiply both sides by 13.
What?
What?
Oh, can I do the cross multiply? Will that work?
Yes, you can.
Okay, you have.
That works as well. Either way, it's the same process either way, yeah.
All right.
And that gives us an answer of times 11.97. So I'm going to call this 11.97. And our force is measured in newtons. So 11.97. Is that a bad color? That gold?
No.
Was that a yes or no? Sorry, London.
Kind of hard to see, but 11 right now.
Okay.
We got 12, 16, right?
Yes, sir. Okay. So,
Sure. Oh, you multiply?
yeah, because if you cross multiply, you get fx times 1 equals 13 times 0.9205.
Oh, yeah. Sorry.
Okay. So, how do we find the y leg?
By using the 11.97 we just found.
You can. That's one way to do it. What's another way? Physics, there's almost always more than one way to answer the question.
By doing it.
Fine.
We could use sine. So we could use sine or we could use tangent. Either way is fine. I would recommend in general,
Sine.
I recommend in general that you don't use a calculated answer again.
Why?
Because if Trevor misses it on the first one and he does the second one with his wrong answer from the first one, now he's missed the second one as well. Does that make sense?
Yeah.
So I tend to only use answers given in the problem, but it's okay if you do the other if you're doing it correctly. And typically, because the way I grade, I don't typically count off the second one wrong if you did it correctly with your wrong number. Because I call that double jeopardy. Like in the US, you're not allowed to be tried twice for the exact same crime. You could be tried for murder, and then you could be tried for manslaughter. Those are two different crimes, but you couldn't be tried twice for murder. Okay.
Murder.
So in this case, what I do is I try to look at your work and see if you used the wrong number twice, but you used it correctly the second time. I don't typically count it wrong the second time. Because otherwise I'd be making one mistake count as two misses. Okay. So now, so here's what I would do. I would go back and go, okay, the y leg, I don't know. I put it over 13 that's given, and that will be the sine of 23. So this would be 13 times the sine of 23. Put that on my calculator.
0.3907.
Say again?
0.3907.
Okay. So 13 times
Double check.
0.3907. Yep. Because it's always good to have two people with the same answer, yeah?
Yeah.
Yep, 5.08. So either round off to 2 decimal places or 1 decimal place. You'll kind of have to decide on your own on that. And that's how we do those kind, which is exactly like what you just had on your solving your right triangles worksheet. So if you don't feel comfortable with this kind of piece yet, do the solving the right triangles and the trig ratios worksheet first, turn those in, and then we can start working on the other one. So now let's put it all together on number 3. So we just did number 2. Those of you that like the ever happy arrow to point to where we're going. We just did this piece up here.
Oh, we already answered it. Right?
Yep, partly. We're going to put the two pieces together now. So what piece do we have now? We have this is 5.08. We have that this is 11.97. And now we do our physics think piece. Should our ups and downs still be balanced? Well, we don't know the scenario, right? I don't know what the scenario is. But it does look like if I was to stick this little piece right on top of that one, it'd be about the same length because this is too long right now. So I would guess this piece plus this piece, the two forces up would balance the one force down. Okay, so what I'm going to do here is this is the statements I'm going to make. So vertically, my forces should add up to 0. So I have a 5.08 up, I have force normal up, and I have force gravity down, and that should add up to 0. I'll stop right there because I know y'all are trying to copy and do. Let's see. So let's see, what would force normal have to be? Force normal minus, see, 19.6, 6, 5.08, minus 14.52 equals 0. So this force is 14.52. Here's an upward force, so it gets a positive sign, force normal. Here's the other upward force. So plus 508 and plus force normal, both up. Gravity points down,
Oh, okay.
so it's a negative sign.
Subtracted
Right.
the 19 of or the 5.0
Right.
from the 19.
So the sign, the SIGN, the plus or minus sign tells you direction. So since gravity points down, we give it a negative SIGN. Now we're almost done. We got to finish up these pieces over here. So what is our net force now? What would go in the net force box? What's the unbalanced amount? Because we just said here, vertically, we are balanced.
So it's horizontally where we're not.
Horizontally, we are not. And what is our horizontal force?
11.97.
11.97. And because from way up here,
We know that it's 1.
we know the mass, we can come down here and go force equals mass times acceleration. So we can solve that one. 6.1. We're dividing. 11.97 divided by 1.96. Okay. So now you've seen all the steps. So what have I done a bunch of times? A whole bunch of times I've done force and mass times acceleration. But I've also used sine and cosine to find some of the bits and pieces. So this is very much like a jigsaw puzzle in a lot of ways. You just start somewhere, fill in what you know, and use that to find some more stuff and keep moving until you get it all filled in. Okay. So, gonna stop as far as stop lecturing and let everybody work for a little while to see where you're getting stuck. We have about 10 minutes before lunch. And that way you can get started. You guys just unmute and holler at me, online folks, or chat in the box, and I'll come back and check around in a minute. I'm gonna walk around the room now though. And if you're good, if you're done, you can leave. Otherwise, hang out with us because we'll be back in here after lunch till 2:01. 2:01. No, you can't. Sorry, man. So there are a lot of steps. I think some of you are a little anxious about the steps, but we'll just start with something you know how to do and work to the next part. When you get finished with any of your work, goes in the green folder, which I will put, actually, let's just put it in the middle right now. Diego and friends are not here today. We'll put that right there. So if you got like the solving right triangles worksheet done, put it in there. If you've got the trig ratios worksheet in there, turn that in. And of course, you've got the lab that you can work on, or you can work on the new packet, whatever you need to work on. And I will, let's see if I got anything to pass out for you guys. So for y'all online, we need this turned in ASAP. And have any solving? And the one that says solving right triangles at the top. Those are the two things to get done and turned in, email to me as you can. Let's see. Emma. This doesn't have grade on it, well, maybe it does. Before the break. Yes, sir, you know, I just said, I'm gonna do this. Okay. Okay. Yeah, it makes sense, but it's not correct. Okay, so what side is this? So if you have adjacent over opposite, is that one? You don't know that part. So we might want to use between your opposite and adjacent. Okay.
That makes sense.
So those are not due till Friday. So you done the other ones?
Yeah, I guess.
Okay. Those are the ones you're finished with, you put in the box. Okay. On this, you cut these out. And then you put the three-body diagram, put it number one, put these down this. Okay. And then you put the picture there. And you can just take a photo of it. You don't have to like glue them down or anything. And then if they're in equilibrium, forces are balanced. So like this one would be in equilibrium because the two arrows are the same length. But that one would not be in equilibrium. So if you're in equilibrium, it makes your forces are balanced, so you have no acceleration. If you have unbalanced forces, then you have to accelerate. So this would be acceleration straight down. And you just match these with these, and then answer, are we in equilibrium or do we have acceleration? Okay? And that took them, sorry, 30, 35 minutes, maybe as much as 45. So don't panic over that. Is there something, are you okay on what we're doing today? Or do you know something? Okay. All right. So where are, yeah, but where were the other ones? These, oh, let's start with these first. So this one, start with that one. Yeah, just start with this one, and all you're doing is you're giving me the fraction. You can just leave it as a fraction on this side. On the other side, you will do, you'll give the fraction, or you'll give it as a, but you'll give it as a decimal this time. 4 decimal places. Okay? So Which ones would be the sides I need for tangent? You know those? Okay. No, it's okay. We do a lot of this sort of stuff. So, sine is opposite over hypotenuse. This one being is adjacent. Tangent is opposite over adjacent. So when we look at this angle, they ask you for tangent, so you see what they're asking about this angle. Okay. So which side would be the opposite side? Mhm. Which one's the adjacent side? Mhm. And then the hypotenuse is always the one that's longest or across from you. So if I want tangent Z, I want it to be opposite leg over the adjacent leg. So that would be 1 over 8, and I would reduce that to 3/4, because 7 goes on both sides. Okay? What about this one? We're looking for this angle. We're looking for this angle. Mhm. Opposite over hypotenuse. So it's 32 over 8. Okay? All right. Okay. Going to stop recording. I may hop back in here in a minute.
Ain't over yet. Overtime. Just make a vote.
I don't know if they are brains on them. Oh, your stuff turned down. Yeah, here's what you turned in before the break.
I got one. There. Oh, I did it, bro. Maybe for lunch, 3 minutes, 4 minutes, or that. You're wanting That's cool.
All right, have a nice lunch.
Right back to you.
Okay, then just go to the green folder. We'll keep everything all together. Bathroom, have my keys on me? No.